Today we're starting section 1.3. This is our second day in the section, and we're going to determine if functions are even or odd, and then we're going to practice evaluating piecewise functions. So our even and odd has a certain rule to evaluating it. So if a function is even, that means we evaluate the function at negative x. So everywhere I would see a x, I would plug in a negative x. And if I get the exact same result as the original function prior to plugging in the negative x, we say the function is even. Same idea for odd. We again are going to plug in negative x. But this time the result's going to be different if I plug in a negative x and I get essentially the opposite signs of the original function. I would say it is odd. If neither one of these scenarios occur, we would say it is neither. Okay, so let's try an example. So our function f of x is equal to x cubed minus 6x. And we're determining if this is even, odd, or neither. So to determine that, we evaluate the function at negative x. So if I plug in a negative x, I have a negative x raised to the third power minus 6 times a negative x. So negative x times negative x times negative x would be negative x to the third power plus 6x. And to determine our options, if it's exactly the same as what I started with, it's even. And you can clearly see it's not exactly the same, so it's definitely not even. If everything is opposite, I would say it's odd. And in this case, you notice every sign is opposite. You could also think of it like this. If I factored out a negative, notice I would get the original, but with that negative in front. So we would say that this function is odd. So let's try the next one. So the next one is f of x equals x to the fourth power minus 2x squared. So I evaluate it again under negative x. So I have negative x to the fourth power minus 2 times negative x to the second power. So negative x to the fourth power will become a positive x to the fourth. And then I'll have minus 2. A negative x squared becomes a positive x squared times that negative 2. So I get minus 2x squared. Notice it's exactly the same as the original, so we call this function even. So one more. So for this example, f of x is equal to x squared plus 2x plus 1. So f of negative x, I plug in a negative x raised to the second power plus 2 times the negative x plus 1. This got a little sloppy, sorry. Alright, so negative x times the negative x is a positive x squared. The middle term will become a negative 2x, and the 1 remains unchanged. So notice all of my signs are not exactly the same. If I factored out that negative, I would have a negative x squared plus 2x minus 1. And notice that this piece isn't the same as the original either, so we would say that this is a neither. To determine if a function is even, odd, or neither graphically, so on a graph, if our function is even, for every coordinate that is an xy, we have the same coordinate that has a negative xy, which means it has symmetry with respect to the y-axis. So we would use this in the instance if we don't have a function to plug a negative x into and just looking at a picture. Our function is odd if for every coordinate x, y, we have a coordinate that corresponds to a negative x, negative y. And this has symmetry with respect to the origin. So the odd function is a little bit more difficult to identify graphically. The even's a little bit easier to do. So just to give you a quick picture of what this would look like. An even function, and then this is our odd. And then obviously if it doesn't suffice either one of these situations, it's a neither. So an even function would look something to this effect. It would be a parabola. And notice if I folded this picture over the y-axis, it's symmetric, just to kind of prove the coordinate that we talked about. So if this coordinate is 2, 3, notice over here I have the same coordinate with a negative 2, positive 3, so the x values change. For odd, it would be something that is cubed. Should be down here, sorry. And this has respect, let me label this. So this has respect to the origin, so we call this odd, and to kind of prove that, notice we have this coordinate here, 1, 1, and then down here we have the same coordinate, negative 1, negative 1. So if both x and y are opposite of each other, then we would say it has respect to the origin. If neither one of these situations happen, then we say it's not even nor is it odd. So the last thing I want to do is going over evaluating piecewise function. We'll do more on this tomorrow. Let me take the graph away. Alright, so evaluating a piecewise function. So if I have f of x equals 2x minus 1 and an x plus 3. And we did do this in Algebra 2 last year. Remember there's these if statements. And if x is less than or equal to 1. So we'll just run through 3 quick problems. So remember here's these 2 completely separate pieces of a function that are pieced together. They have 2 conditional statements as to when you can use them. So if I gave you the value f of 3, you would first have to determine which of these inequalities it's true in. So out of these 2 inequalities, the value of 3 is greater than 1. It's not less than or equal to 1, which means I'm using the top equation. So all I have to do is plug in 3 into the top equation. So I have 2 times 3 minus 1, so 6 minus 1 is 5, and this is our final answer. Notice you're not plugging into both. You're only plugging into whichever piece it is true. So f of negative 4. So again, if I plug negative 4 into both pieces, negative 4 is not greater than 1. Negative 4 is less than or equal to 1. So I plug it into the bottom. So I have a negative 4 plus 3, which is negative 1, and that is our answer. And one more, letter C, is f of 1. So again, we got to figure out which place it is true. And 1 is not greater than 1. 1 is less than or equal to 1. So that means I'm plugging into the bottom equation again because it has the equal to piece. So 1 plus 3, So 1 plus 3 is 4, and that is the answer for the last piece. So that's all for today. We'll pick up with this tomorrow.